All right, let's start with the first question. I like to factor out the GCF. Okay, if you look at these two, right, you can see first of all there is a y plus 2 here that is a common factor, right? But then also you can see there is a y as a common factor and there is a 3 out of 6. Let me rewrite this. So 6 is 3 times 2, and then you have y, and then you have y plus 2. That's the first term. 3 times 2, that would be 6. This is y plus 2. Now the second term is 3 times y, because y squared, we add the exponents, that's how we got the y squared, and then multiplied by y plus 2. Notice that I have y plus 2 here, I have y plus 2 here, so this is one common factor. I have a y here, and I have a y here. This is another common factor. Then I have a 3, and I have a 3. So these are my common factor. Let me put them all in one. 3, y plus 2. So this is called the GCF. It's the common factor among the two terms. The next thing I want to do here, I want to open two parentheses and I want to figure out what's left from the first term. I have taken off 3, y and y plus 2. Only 2 is left from the first term. Then I have a plus sign here. What's left from the second term? I have 3, y plus 2. Only y is left from the second term. And this would be my final answer. So that's what we call factoring using the GCF. You got to look at each term, factor everything out, and then see what is common. In this case, 3, y, and y plus 2 are common to both terms. Okay, so this is 3, this is y, and this is y plus 2. So this is called my GCF. So this part here is called my GCF. So I take my GCF and then I open two parentheses and list what is left. So only 2 is left from the first term and only y is left from the second term. So that's what I do here. And that's it. You can always multiply all through to go back to the first polynomial. Solve the equation using the zero product rule. Separate multiple answers using commas if necessary. Okay, so this is called, this x is multiplied by 4x plus 7 and we are getting a 0. Let's remember, if you multiply 3 times 5, would you get a 0? No. If you multiply 2 times 4, would you get a 0? No. The only time you get a 0 when you multiply by a 0, or 0 times 5, right? So here we must have a 0 to start with in order to get a 0. If you don't have a 0, you're not going to get a 0. So here we are multiplying two numbers and we're getting a 0. So maybe, I don't know, maybe x is a 0, or maybe the second factor is a 0. Can we solve for x? Yes, we can subtract 7 from both sides. This is called the addition principle, and 4x would be negative 7 because these two will cancel. Then x would be, divide both sides by 4. X would be negative 7 over 4. So the solution for this problem would be 0 and negative 7 over 4. That would be the final answer. So basically, anytime you have two factors multiplied, or 3 or 4 factors multiplied by each other giving you a 0, then you have to try each factor at a time, equate to 0 and solve for x. The first one was just x equal to 0. We couldn't do anything else because it's already isolated. X is already isolated. So x equals 0. On the second one, we had to subtract 7 from both sides and then divide by 4 to isolate x. All right, let's go to the next one. We have a polynomial 4 u squared plus 49v squared. The question is, what can a polynomial or binomial is? It difference of two squares? No, it's not. Difference of two squared is like x squared minus 4. This is difference of two squared. That should be a minus between the two squares. Sum of squared, yes. This is sum of squares. This one is sum of squares. Okay? So now can we factor? No, we cannot factor. This cannot be factored. And it is called a prime. It cannot be factored and we call it prime. Okay, because look, if you factor 2u plus 7v times 2u plus 7v, you're not gonna get the answer here because there will be an outer and inner which is not there. What's the outer? 2u times 7v, which is 14uv, plus the inner 14uv. So this number, which is 28uv, is not available here, and that's why we cannot factor this binomial. So remember, the sum of squares cannot be factored. If they ask you to factor x squared plus 4, you would say prime. The sum of squares cannot be factored. Factor out the GCF. Okay, we do the same like before. 12 can be written as 2 times 2, 4, times 3, 12, times A, times B, plus 9 can be written as 3 times 3, times A, times A, times A, times B. Now we're going to find out what's common. Okay, 2's are not common. The only common is 3. So we have a 3 here, and we have a 3 here. Also, we have an A here, and we have an A here. And then we have a B here, and we have a B here. So the GCF is going to be 3A, B, and we always open two parentheses when we factor the GCF. So if you remove 3AB from the first term, what is left? 2 times 2, which is 4. If you remove the 3AB from the second term, you're left with 3 times A times A. What is A times A? We add the exponents. 1 plus 1 is 2, and this would be 3A squared. And that would be the final answer. So this can be factored, therefore it's not prime. Anything that can be factored is not prime. Anything that can be factored is not prime. Anything that cannot be factored is prime. In this case, we were able to factor, therefore this was not prime. Factor the polynomial, and this is what we call the difference of two squares. Difference of two squares. And you notice it is difference. We have a minus sign. This is a perfect square because it is 7t times 7t. This is also a perfect square because it is 6 times 6. And therefore this is the rule for difference of two squared, or this is the pattern. A squared minus b squared is always going to equal to a minus b, a plus b. A squared minus b squared is always going to equal to a minus b, a plus b. So you take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Let's apply it to our polynomial. 49 t squared minus 36. The square root of the first is 7t minus the square root of the second is 6 times square root of the first 7t plus the square root of the second, which is 6. Final answer. Factor completely. This is called a trinomial. The degree of this trinomial is 2. because the highest exponent is 2. Okay, to factor, we're going to open 4 parentheses. Since the leading coefficient is 1, so this is called the leading coefficient. It's always the coefficient of the term with the highest exponent. We call it the leading coefficient. Since it is 1 and we want to factor, we're going to look at 8. Call it the product of 2 numbers. So 8 is the product of 2 numbers. Give me 2 numbers, you multiply them by each other, will give you 8. Well, we either have 4 times 2 or 8 times 1. That's all. 8 can be either 4 times 2 or 8 times 1. But when I look at this 6 here, this is the sum of the 2 numbers. And I want the sum to be equal to 6. So I cannot choose 8 times 1 because the sum is 9. So that's going to be out. I'm going to eliminate this option. But 4 times 2 is 8 and the sum is 6. Therefore, I'm going to use 4 and 2 and I'm done. W plus 4, W plus 2. We can check. W times W is, you add the exponents, it's W squared. W times 2 is 2W. 4 times W is 4W. And 4 times 2 is 8. These are called like terms. We can combine because they are called like terms. And therefore the final answer is 4W squared plus 6W plus 8, which takes me back to the original. Therefore the answer is W plus 4 times W plus 2. So that's the complete factoring. W plus 4 times W plus 2 is the final answer. Another factor completely. Again, this is a trinomial. So it's nice to identify your polynomial before you start factoring. The degree of this trinomial is 2. It is the highest exponent of z in this case. The leading coefficient is 1. It's the exponent of, the coefficient of z squared is 1. Therefore, the only thing we need to do here is find 2 numbers. Their product is 28. Their sum is negative 11. What are those 2 numbers? So basically we're getting the sum to be negative 11. So there is a negative involved in this trinomial. The product is 28. So we can get 4 times 7, that's 28, right? And 14 times 2, that's 28. And 28 times 1. All of these will give me 28, but I want a negative. So let's try negative 4 times negative 7, negative 14 times negative 2, and negative 28 times negative 1. So still, if you multiply negative times negative, you're going to get positive. But when you add them, you're going to get negative. And this works because negative 4 plus negative 7 is negative 11. The others, 14 and 2 is 16. It's not going to work. 28 plus 1 is negative 29. It's not going to work. So the only option here would be z minus 4 and z minus 7. This is not prime, right? Because it can be factored, then it is not prime. Also, the order is not important. You can start by z minus 7 times z minus 4. So order is not important. This is the final answer. Either this one or that one. Okay, so the idea is to look at the last term, find 2 numbers, their product is 28, but then looking at the coefficient of z, which is negative 11, we want the sum to be negative 11. Therefore, 4 times 7, we cannot use 4 times 7. We have to use negative 4 times negative 7 because the product is 28 and the sum is negative 11. That's why we had to choose negative 4 and negative 7 for the factoring. Factor the polynomial p squared plus 2pq plus q squared. Now this is also a trinomial. Now it is confusing because we have two variables this time, but it's still a trinomial because you have 1, 2, 3 terms. Also the degree is 2, so that applies. Degree is 2. And the coefficient or the leading coefficient is 1. Therefore we can use the same rule. Let's open 4 parentheses. Let's look at this one. We want the product to be q squared. Product equals q squared. And we want the sum to be, now if we assume that p is the variable, right? So let's assume, remember when we do x squared plus 5x plus, let's see, 6, right? We always assume that x is the variable. But since here we have two variables, I want you to assume that p is the variable and q is like 5 and like 6. It's a constant, okay? So in this case, if the product is q squared, what would be the sum? Assuming p is the variable, the sum would be 2q. And that's pretty simple because the product is q squared, that would be q times q. The sum is 2q, that would be q plus q. So we're done. So this is going to be p plus q, p plus q. Okay, look at this. What is p times p? That will give me p squared. Let's go the inner and the outer. The outer is pq. The inner is pq, so 1pq plus 1pq will give me 2pq, and then q times q is q squared. Now anytime you have two factors the same, p plus q times p plus q, then you can write them as one factor and then with a square. And this trinomial is called a perfect square trinomial. A perfect square trinomial. So the only tricky part about this problem is having two variables, but again I want you to assume that p is x in this case, and the q squared are the constant, like 2q would be 5, q squared would be 6, okay? So when you look at the product, you want to look at the last term, you want the product to be q squared, and you look at 2q as the constant part, the coefficient of p, to be the sum. So give me two numbers, their product is q squared, their sum is 2q, the numbers are q and q. Because q times q is q squared, q plus q is 2q. So going back here, the variable plus q, the variable plus q. But they're exactly the same, that's why you end up writing this as p plus q to the quantity squared, and we call this trinomial a perfect square trinomial. Again, factor completely. Leading coefficient is 1. Okay, the trinomial, this is a trinomial, leading coefficient equals 1, degree equals 2, the highest exponent of x2. So always we look at opening 4 parentheses, we look at this as the product, we look at 2 as the sum. So give me the two numbers, their product is negative 15. So one of them is going to be positive, the other one is going to be negative. So we're trying to find two numbers, one negative, one positive, whose product is negative 15. Let's try 5 times 3. But negative 5 times plus 3 is negative 15. But the sum is negative 2 because negative 5 plus 3 is negative 2. But we want plus 2. So that's why we have to switch the minus sign here. And we take 5 times negative 3. We still get negative 15, but when you add them, 5 plus negative 3, that's going to give you a plus 2, which is exactly what we have here. So that's the answer. X plus 5, x minus 3. Notice that x times x will give me x squared. 5 times negative 3 will give me negative 15. The outer is negative 3x. The inner is 5x. If you add them, 5x minus 3x, you get 2x, and that's the middle term. That's the final answer. This is factoring completely. This is not prime. It is not prime because we were able to factor it. So again, when you factor, it's a trinomial. You look at the last term. This would be the product. The coefficient of x would be the sum. Now you have to be careful about sign. Because this is minus, then we have to have each one different sign, right? We tried negative 5 times 3, we get the product negative 15. But when we tried the sum, negative 5 plus 3, it's negative 2. We don't want negative 2, we want plus 2. That's why we switch the sign. 5 and negative 3. 5 times negative 3 still gives me negative 15, but when I add them, I get plus 2. That's why I chose x plus 5, x minus 3 as the final answer. Identify the greatest common factor. Okay, let's try again. 8, 2 times 2 times 2. M times m times m. That's m cubed. And then 1n. The other one is 16. It's 2 times 2 times 2 times 2. Because 4 times 4 is 16. M squared. M times m. And then 1n. Alright, let's start. We have 3 2's. So we're going to take the 3 2's here. We have 2m common factor. 2m. And then we have 1n. We have 1n here. Okay, and this is called my greatest common factor. 2 times 2 times 2 would be 8. M times m is m squared, and then n. This is my GCF. When we factor GCF, do we have to factor? Identify the greatest common factor. So that's the final answer. We don't have to factor this time. If the question was to factor, then you would open 2 parentheses, and what is left from the first term? M. And what is left from the second term? 2. And that would be if the question was to factor. But since the question is identify the greatest common factor, this is my final answer. My greatest common factor is 8m squared n. What you need to do is go back and check your work again. Okay, go back and check your work. You have 2 times 2 times 2 here. They are common. So that's where the 8 came from. We have m times m. M times m is common. That's where the m squared came from. And then we have only 1n common. And that's where the n came from. Okay, notice that on the first term, m is left. So that's why we put it in the second factor. On the second term, only 2 is left. And that's why we put it in the second factor. And that would be the final answer in this case is 8m squared n as the GCF among the 2 terms. Factor the polynomial. Notice this is a perfect square and this is a perfect square. So this applies to difference of 2 squares. We're going to use the same pattern, which is a squared minus b squared. Remember, it's a minus b, a plus b. We're going to do the square root of the first minus the square root of the second. What is the square root of this guy? It's 16 is 4 times 4. And n4 is n squared times n squared, right? So then 4n squared would be the square root of 16 and 4. What is the square root of 81? That's 9. So that's my first factor. My second factor would be 4 n squared plus 9. One more time. This is called a difference of 2 squares, right? We have 16 and 4 is called a perfect square, and 81 also a perfect square. So the square root of 16 is 4. The square root of n4 is n squared. Because remember, if you multiply 4n squared times 4n squared, you will end up with 16, and then we add the exponents n4, n to the power 4. That's how we got the 4n squared. The square root of 81 is 9. And therefore, a minus b, a plus b. That's how we factor. But notice here, notice that 4n squared minus 9 is also another difference of 2 squares. So we can factor this one, but this is called the sum of squares. The sum of squares is prime. We cannot factor. This is prime. I'm referring to this one here. This is called the sum of squares, but it is prime. We cannot factor. We can factor this one more time. Okay, take the square root of this. 4n squared, it's 2n times 2n. Square root of 9 is 3. So 2n minus 3, 2n plus 3. Using the difference of squares, a minus b, a plus b. And then keep the same sum of squares because it is prime and we cannot factor it anymore. So the final answer is 2n minus 3, 2n plus 3. That would give me 4n squared minus 9. And then 4n squared plus 9 is not going to change again because it is prime. We cannot factor it. This one, we were able to factor it because it is difference of two squares. Okay? So this one we were able to factor it because difference of 2 squared is going to go 2n minus 3, 2n plus 3. Always we do the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. Remember that 4n squared is equal to 2n times 2n. Why is that? Because 2 times 2 is 4, and n times n, we add the exponents, will bring me n squared. And therefore this is the final answer. We cannot factor anymore. Now solve. Solve is a new, we haven't done any solve in this review test, but before we solve, we factor. So step 1, we have to factor. And step 2, we use the zero product rule to solve. So 2 methods or 2 steps before we solve. Okay, let's factor. This is difference of 2 squares. 25m squared is 5m minus 7, 5m plus 7. Again, I'm using the difference of the squares pattern. You gotta go a minus b, a plus b. That's what I did. Because 5m times 5m is 25m squared. 7 times 7, 49. Make sure that this is equal to 0. Once we factor, we need to use the zero product rule. Remember what I said? The only time you're going to get a 0 when you multiply by a 0. So 5 times 0 is 0. 0 times 7 is 0. The only time you would get a 0 is one of the factors should be 0. So here, one of the factors, we don't know which one. Let's equate each one to 0. So 5m minus 7 equals 0. Let's isolate m. First add 7 to both sides. Then divide both sides by 5. So m would be 7 over 5. Do the same for this guy here. 5m plus 7 equals 0. Subtract 7 from both sides. And divide both sides by 5. And so the solution is plus or minus 7 over 5. You can write this inside braces. Minus 7 over 5 plus 7 over 5 as the final answer for this problem. Okay? So minus 7 over 5, 7 over 5. This is your final answer. These are the values of m that will make this binomial 0. You can go back and check. What is 7 over 5 squared? 7 times 7, 49 over 25. The 25 will cancel. 49 minus 49, 0. Negative 7 over 5. When you square a negative, it becomes positive. So you're going to end up with 49 over 25 again. 25 will cancel. 49 minus 49 is 0. That's how you check your work. So by checking, you take the value, you substitute in the original equation, and then you try to see if you get 0. And we got 0 on both attempts. Solve the equation using the zero product. So this is already factored. Please don't go and don't FOIL or don't multiply. Make sure you don't multiply here. It's already factored. Why would you multiply? You're going to use the zero product rule. Zero product rule. What is zero product rule? You equate each one to 0. So x minus 2 equals 0. Add 2 to both sides. And no need to divide because x, there is nothing here. So x equals to one option. The second option, equate x minus 5 to 0, add 5 to both sides. X equals 5. Final answer, 2, 5, and no need to, or we can check if you want. Let's go and check. If you have 2, 2 minus 2, 0. 0 times any number is 0, or if x equals 5, 5 minus 5, 0, and 0 times any number is 0. So most students would start by multiplying. You're trying to solve. You want to find x equals how much? All you have to do, equate each factor to 0 and solve for x. So solve means x equals how much? So it's not saying multiply. If you multiply, it's going to take you double the time to solve this problem. Solve the equation. Okay, so again we're solving. So we're going to do a couple of steps. We're going to factor first and then use the zero product rule to solve. So again, solving means a couple of steps. Again, the t squared has a leading coefficient of 1. So right away we open 4 parentheses. We want the product to be 15. We want the sum to be 8. So what are the two numbers? 3 times 5 equals 15. And notice everything is positive, so we don't have to worry about the negative sign. 3 plus 5 is 8. We're done. So this would be t plus 3, t plus 5 equals 0. Order is not important, right? You can do t plus 5 times t plus 3. You can check. Outer is 5t, inner is 3t. 5t plus 3t is 8t. t times t is t squared. 3 times 5 is 15. We're done with the factoring part. Now let's move to the zero product rule. Equate each one to 0. Subtract 3 from both sides. First solution. Equate t plus 5 to 0. Subtract 5 from both sides. T would be negative 5. Final answer, negative 3, negative 5. Okay? Some students would look at this and say, oh, the final answer is 3, 5. No, that's not 3, 5 because 3 plus 3 is 6. It's not 0. You want this to be 0. So it has to be negative 3 plus 3 or negative 5 plus 5. Solve the equation. Again, don't multiply. You're trying to solve. It's already factored. Don't multiply and spend time for nothing. So either this is 0, it's already x, so we don't have to do anything, or this is 0, 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3. Then divide both sides by 2. X would be 3/2. Therefore, the solution is 0 and 3/2. So most students, they start by multiplying, but you are solving. It didn't say multiply. No, it said solve. So to solve, you have to go factor and zero product rule. It's already factored, so we skip this part. We move to the zero product rule, equate each factor to 0, and solve for x. So you want to find what is x equal to when you solve. You don't want to multiply, please. Factor out the GCF. So in this case, the question is factor. It's not solve. Factor, what do? We take a times a for the first, 3b times b, c times c times c. Now, do we have a? No, we don't. So there is no common factor here. So we're going to say this is prime. It cannot be factored because there is nothing in common. There is no 3 here, there is no b here, there is no c here, and there is no a here. So this is called prime. Factor completely. This is a trinomial again. A trinomial with leading coefficient 1. Remember, there is a 1 here you don't see. And also there is a a leading coefficient of 1, and the degree is 2. So make sure you know all these steps before you start factoring. Open 4 parentheses. Now we want the product to be 10, so that's 2 times 5, or 10 times 1. We want the sum to be negative 7, so s equals negative 7, and well, because the sum is negative, these has to be both negatives. And negative 2 plus negative 5 is negative 7, so we're done. So x minus 2, x minus 5. And this is how you confirm this is right. The outer is negative 5x. The inner is negative 2x. Their sum is negative 7x. And that's the middle term. And that's the middle term. All right, let's go to another example here. How to identify the greatest common factor. 3r cubed. This is 3 here. And we have a 3 here because 6 is 3 times 2. And we have a 3 here, which is 3 times 5. So 3 is a common factor, the greatest common factor. Now, between the exponents, we have r cubed, and we have r to the power 1, and we have s to the power 7, s to the power 4. So always pick the one with the lowest exponent. To find the GCF, pick the one with the lowest exponent. Between r cubed, and r squared, I'm going to pick r. Between s4, s6, s7, I pick the one with the lowest exponent. That's s4. Between t4, t4, and t cubed, I'm going to pick the one with the lowest exponent. That's t cubed. And this would be my GCF. So this is a quick way of finding the GCF. You always, first for the numbers, you have to see what's common between the numbers. But for the exponent notation, you pick the one that is common with the lowest exponent. And that would be the final answer. Factor completely. Again, we've done this. This is product is negative 28. That's 4 times 7. The sum is 3. Okay, I want the product to be negative, so one of them should be negative. Which one I'm going to pick negative? The negative 4. Why is that? Because negative 4 plus 7 is plus 3. Therefore, I pick the negative 4, and I pick the plus 7. And why is that? Because the outer is 7z, the inner is negative 4z, and their sum is 3z, and that's what I need here. I want a plus 3z. I satisfied everything because negative 4 times 7 is negative 28. Z times z is z squared. The middle term is satisfied by adding the outer plus the inner. 7z minus 4z equals 3z. Solve the equation. First we factor. Let's go ahead and factor. We want the product to be 8, the sum to be 6, so w plus 4, w plus 2 equals 0. The product is 8, the sum is 6, right? So we're done. All we have to do, equate this to 0, w equals negative 4. Equate this to 0, w equals negative 2.